Okay, let's continue.
Okay.
So arrangement of electrons, we already know. We know SPDF, we know groups, we know periods, and you know metals and non-metals.
Yes.
What are
Yeah.
metals?
Metal. Oh,
Metals are the ones that always have a positive charge, and the non-metals are the ones that have a negative charge.
They can also
Yeah,
like
metals
non-metals can
always
also
lose,
share.
and
They can also share.
yeah, and then the non-metals always gain and share.
Okay. So Kyra, what you were saying?
I was saying that the non-metals can also share.
Yeah, that's really good. You girls are smarter than AP children. Okay. Now, Aditi, you're okay with that?
yeah, I kind of forgot about it.
It's okay. Metals, they lose electrons. Non-metals, they gain and share. Okay. Now, today we are going to do, again, we are working with the periodic trends. Part 4
Oh,
of
yeah.
that PDF. Part 4 or 5? Part 5, right?
Yeah.
So we are working with the periodic trends, and now today I'm going to teach you the periodic trend of metals and non-metals based on attractions, periodic trends. So last time we did sizes, am I right?
Yeah.
Yes.
Yeah, we did
Yeah.
sizes.
We did the sizes. Today we are going to do metals and non-metals. The trend of the metal and non-metals. It's very easy to understand. So first, let's try to understand what is a metal again. Metals are something which can lose electrons. They always lose. They never share. Okay, I cannot say like this, they never share. There are some examples, but you just take it for your level. They always lose electrons, right? And when they are losing electrons, what is the charge they are getting?
What's
Plus.
the N?
Positive.
What's the N plus?
And here is the charge. N plus is the positive charge. It can be 1 plus, it can be 2 plus, it can be 3 plus, right?
Okay. So N is unknown.
Yeah, like for example, if a metal is losing only 1 electron,
Or yeah, a variable.
then what is the charge on it?
1 plus.
1.
1 plus.
One
If it is
plus.
losing 2 electrons,
Plus.
Then
plus.
2 plus.
If it is losing 3 electrons, 3
3
plus.
plus.
You know this mathematics very well?
Yeah.
Okay. So metals, they lose electrons. Now, you people are going to help me in understanding the trend. First of all, this is called as metallic nature. So what is the metallic nature? Metallic character or metallic nature. What is the meaning of that? A tendency. It is the tendency to lose electrons.
Metallic
Yeah.
metallic character or nature.
It's the tendency to lose electron. It's a property, right? Metallic property. You can call it as character, nature, or you can call it as property also. Metallic property. So what is metallic property? The tendency to?
Tendency to lose electrons.
The tendency to lose electron.
Yes. Remember that. Now the question is for you. There is a very big atom and this is the outermost shell. Electron is here and nucleus is here. Positive. There is a small atom and electron is here and nucleus is here. Which atom has more tendency to lose electron?
I have a question.
Mm-hmm.
Do you mean the for metallic character above it says the tendency to lose 2 electrons?
No, any number.
Or is it the tendency to lose?
Any number. Any number. That's why we have taken n plus, right? Some metals, they lose only 1. Some metals they lose 2, some metals they lose 3. But losing more than 3 is difficult. Why?
Because it's
Because
not nature
energy
doesn't
It'll lead to like
it,
really destructive things.
and nature
Okay.
doesn't.
Destructive things.
Yeah.
Okay. What you were saying, Aditi? I think Avni already answered it. So Aditi,
Nature doesn't like
permit. Why nature is not going to permit?
because nature
It's
likes low energy.
It's
Nat-
unstable and it has high energy.
yeah, high energy is needed. It's very expensive energy wise. Like
Oh,
when you
okay.
go to the market, but you want to purchase something which is very expensive out of your pocket, you will not purchase, right? You come back. Same here. Nature is not going to make element lose more than 3 because it's very expensive energy wise. Very large amount of energy is needed. Okay, now check this. Element A, element B, in which case the electron is more strongly held by the nucleus, in A or B?
B,
B. Why?
because it's
Because
closer to the
when they're more
nucleus.
closer, it's more attracted.
Yes, when plus minus are more closer. Did I tell you Coulomb's law?
Oh, yeah,
I
you
think
told
it
us.
did, yeah.
Okay, then
I
look at the
remember,
Coulomb's
yeah.
law. F is K
What's
times
that?
Q1 Q2 over R squared.
Like,
What
oh,
is
the
Q1 Q2?
force Q1, Q2 over R. Q1, Q2 is the charges, and then R is the distance of
Between the
what?
charges.
Oh, yeah.
R is the distance between the charges. Here the charge is electron and the nucleus, right?
Yeah.
So if the
So,
distance is more, force of attraction
Is less.
yes,
Is
yes.
less.
Inversely, can you see inversely? And this is directly. Distance of separation of charges. What is the name of this law?
Coulomb's law.
Yeah.
Coulomb's law. Yeah. Oh, I remember we did an exam.
You did in where?
We did a lot of examples.
Yeah, we did this exam. Okay. It's one of the basic thing in chemistry. If you want to understand, as I said earlier also, most of the chemistry you can easily understand by checking the attractions and repulsions. Okay, so in which case it is hard or difficult to remove electron in A or B?
In B.
A. Wait.
In A, because A has more stronger attraction with the nucleus, right, Aditi? Oh,
Isn't that
sorry,
What?
B?
B,
Isn't
yeah,
that
in
B?
B. I was looking at B, but saying
Oh,
A.
I was confused.
In B, there is stronger attraction between electron and the nucleus, right? It's stronger. So stronger attraction means more energy is needed to break that attraction. Means difficult.
Oh,
B has more difficulty to lose electron. A has more easier way of means less energy. It's more easy for A to lose electron. Is it okay? So write on. Big atoms, big sized atoms can lose electrons easily. You can give the reason why?
Because there's less
Because
attraction.
there's less attraction because the
Less
distance from the
attraction.
nucleus to the electrons is farther.
Yeah, please write on this why in your notebook.
Oh, okay.
Write on the why also. Big size atoms can lose electrons easily. Then which one is more metallic, A or B?
Is it A?
It
A.
is A, yes, because A can lose electron more easily. So after Y, you are going to say A is more metallic. More metallic in nature, right? More metallic character, more metallic property, more metallic uh, nature, whatever you want to say. So A is
I
more
can't
metallic.
see,
Mhm. You cannot see what?
see all of the writing.
Maybe your Zoom meeting is minimized. Then just see where is Z, and then there is a arrow like this. Click on it. What happened? Can you see
Still
now?
can't see it. No, I still can't see it. I saw it just now. Oh, wait, no, I still can't see.
Just see where is zoom.
I can
Aditi,
see I can only see big sized atoms can. And then that zoom thing you drew. I can't see. Oh,
can you see
never
the
mind.
periodic table? Mm-hmm.
Yeah, now I can see it.
Here.
It's just my
A is more metallic in nature. Is it okay? Avni? Okay. Now let's see what happens down the group to atomic size. Group. What happens to the group down the group to the atomic size?
It changes.
Bigger.
Okay, 1 second. Now some problem for my side again.
What was your question again?
What happens to atomic size down the group?
Oh, it no.
It goes bigger.
Yeah, wait.
It goes bigger and there's like less
Oh yeah, it
attraction from like
increases.
the valence electron.
Okay, that's the right answer. Okay, I'm writing here what you said. So please write down the group. You know the reason why the atomic size is increasing?
Because the periods are increasing, so the shells are
More number
increasing.
of shells.
Yeah, number of shells are
Number of shells.
increasing.
The number
And
of cells increasing.
Screening, if screening is also increasing. Z effective nuclear charge is decreasing, right? All three things we were discussing last time. Size increases. So as size increases, what happens to this tendency of losing electron?
It grows.
Yeah, it increases.
It
Tendency
grows.
to lose electrons means you need less amount of energy to remove electron because attraction decreases. Tendency to lose electron increases. So what happens to metallic character?
It increases.
Yes, metallic character increases. Aditi, we are okay with this?
Just writing it down.
But you are understanding also?
Yeah.
Okay, good.
Increases.
Now let's see the second. Aditi, this is okay because you can see here. Children, make this diagram also in your notebook so that in future, if you're looking at your notes, down the group, atomic size is increasing. This is first element. This is second element. This is third element. Fourth, fifth. You see that size increases, right? Now this is the electron and this is the nucleus. Electron, nucleus, electron, nucleus.
Distance.
Yeah, see the
farther
distance.
from each other. They're
This
more
is,
separate.
yeah. Now you can use Coulomb's law for the explanation, right? The distance of separation of the electron with the nucleus is increasing. So it becomes force of attraction.
Force of attraction
Yeah.
is
Attraction is
less.
Yeah, decreasing.
Yeah, it's decreasing.
So it becomes easy to
lose
remove.
electrons. It's more metallic as it goes.
Yes,
Yeah, more
like this. Yes, like
More
this.
metallic.
Yes, like this. So make this picture and write down the Coulomb's law. Q1, Q2 over R squared. And then say this R is increasing. R. You can see it is increasing. This is R. This is R. This is R. R. R.
Okay.
R increases, force of attraction decreases. Up arrow increasing, down arrow decreasing. So tendency to lose electron increases. That I have already written here.
So R is increasing, so the attraction decreases.
Yeah, because R is inversely proportional to force of attraction in the formula, right?
Yeah. Wait, doesn't inverse. Wait,
Inverse means one increases, other decreases.
that doesn't inversely proportional mean
Mm-hmm.
decrease in yeah.
Is it
But
okay?
it doesn't mean they're equal, right?
No, they are not
Like
equal. Like R is here in the denominator. If I increase this R, this complete value will decrease, right?
so if you increase a number, the other number increases, but
That's the direct.
they aren't equal. That's right.
They are not equal. Proportional means that they are related to each other. If one increases, other increases. One decreases, other decreases. Inversely proportional means one increases, other decreases. But they are not equal.
Yeah.
So we are good with this? Okay, fine. So that's down the group. Now let's work across the period. Ready? Across the period. Now you start saying, Kyra, you start
Across
first.
ac-
Yeah, who is
Across the
speaking?
um,
Let's give the turn to Kyra first, then Aditi, and then Avni. Yes, Kyra, across the period, what happens to atomic size?
across the period, the atomic size goes more like there's more like electrons, like valence electrons, and I can't remember. Wait, can I look back in the note?
You're going in the wrong direction. Across the period, valence electrons are more down the group. Okay, yeah. Okay, fine. The word is right.
They have more they're more electrostatic.
There
more
is more
attraction,
protons inside the nucleus, right?
so they become more. There's more attraction.
Yeah.
Basically,
And what is happening to the number of shells across the period?
the number of shells are staying the same.
And number of the screening effect? Okay.
That's
Okay, wait. Let's see what Aditi is going to tell us. Aditi, what happens to the number of shell across the period?
It's increasing.
Why, Aditi? How many
Or
shells are
no, if
there?
you go across, never mind. If you go
Yeah,
across the period,
yeah. Say again. What
it's
happens to
staying
number
the
of
same.
same? What happens to screening effect? Screening effect is done by the inner shell. So what is the inner shell in lithium? Helium.
Helium.
Helium, right? And
Yeah.
beryllium,
Helium.
boron.
So they all stay the same. The inner shell stays.
Yes. So inner shell is same, Kyra, right? And the screening is done by inner shell. If inner shell is not changing, then screening effect is not changing. Then what is changing? Yes,
the
Aditi, what is changing?
The number, the atomic
Number.
mass.
No, don't worry about
Not.
atomic mass. Nothing doing with
No.
atomic mass.
I think
It's the. It's.
electrons.
I
That
forgot
is
what it's
changing.
called.
What
It's
else
the
is
number.
changing?
It's the.
You have to
It's
think
the
in
number.
plus and minus.
Like
I think now
there's
let's give
positive
charge.
one.
Yes, plus
Yeah,
one.
charge
Let's
plus
see what
one.
Avni is going
Yeah.
to tell us. Avni, can you explain us?
Yeah, so basically the valence electrons are changing across the period. Um, basically, yeah, the valence electrons are changing, and
See,
I
you
guess
have.
you could say the charge is changing, but that's between like because some places have metals and some are non-metals, so you could say that, but
Okay,
it's not
okay.
changing constantly.
Okay, fine. Okay, so I think all you three are missing one thing. Across the period, the size will be dependent on the attraction of the nucleus with the valence shell. Agreed?
Yeah.
Size means the attraction between the valence shell and the nucleus. Correct?
Yeah.
Now
Yeah.
you are saying number of shells are same. So that factor is out. They are same. Now you are saying inner shells are same. So screening effect is out. Now, how can I compare the attraction of lithium outermost shell with the nucleus? What is changing? The
Oh, the
change.
number of protons. So the attraction is.
Yes.
Oh, yeah.
Yeah.
I keep on forgetting.
Yeah. I said in between, but you didn't hear. So the protons are changing. As the protons changing, what is happening to the attraction?
It's
There's like the
increasing.
cloud of
Increasing?
electrons are going more closer to the nucleus.
So as
So
the
the
protons are
distance between
increasing,
them,
more
More
attraction.
electrons are going closer to the
distance
nucleus, so the
between-
size is like getting kind of smaller.
Yes,
Smaller.
please write down. Yeah.
the distance is increasing.
So let's write down everything again. So we are working across the period. Across the period. Left to right. So generally we say left to right. Left to right. Size. Size. Left to right size. Yes,
Oh,
Avni?
the
Size gets
size
smaller.
is decreasing, but the distance
Decreasing.
is increasing.
Yeah.
It decreases.
Because what increases, Aditi? What did you say?
Distance increases from the nucleus and the
What are you
No,
saying?
it decreases. It decreases.
no.
Because the
Size.
protons pull the electrons closer.
So, okay, don't worry. Write down the reasons. Size decreases. Why? We all are doing error in this.
Oh
Sorry.
wait, never mind.
It's okay. First is number of shells not changing. No change. So whatever is not changing, you are not going to consider it. Second, number of electron inner shell. You can write inner shell. You know the meaning of inner shell? Inner shell, no change, right? Number of shells, no change. Inner shell, no change. Third, number of protons inside the nucleus are increasing. Protons are increasing by 1 unit. Increasing by 1 unit. So reason number 1, we are not going to consider. Reason number 2, we are not going to consider. Only reason number 3 is left. And with this reason number 3, attraction is increasing. Right? Attraction increases. As attraction increases, size decreases.
Decreases.
Is it okay? Size decreases. So as the size decreases, so let's draw the picture for the size. So I'm writing here. Let's make the picture. This is a big atom. I'm moving across the period. What is happening to the size?
It's slowly
decreases.
decreasing.
So what is happening to the force of attraction between the outermost electron
It's
and the
getting
nucleus?
stronger.
It's getting
So-
it's getting
The
greater.
attraction is
So what is happening to the tendency to lose electron?
It's
Um,
not
wait, no,
decreasing.
Getting
it's,
like
it's
less
decreasing.
like
Yeah, so what is
I-
happening to
how it
metallic
goes,
character?
there's less metallic.
Metallic
Why is
character
metallic?
is
The
increasing.
metallic property gets
No,
less as it goes
Yeah,
down.
it's decreasing. Yeah.
That's why
It's
Avni was saying I'm confused across the period, metals, non-metals, both of them are there. Why? Due to size, Avni. As you move from left to right, size decreases. Elements are getting converted from metals to non-metals. Very small atoms are non-metals. Very big atoms are metals. Right?
I had a question.
Mm-hmm.
So basically, I know, like, yeah, you just said that, that, like, the metals and there's metals because it's like larger and the non-metals because it's getting smaller, but like what's the exact size that like determines like this is larger so this is a metal and this is smaller so this is a non-metal, so what's like the size, what's the cutoff?
There is no cutoff. It's not like we have the cutoff in the colleges. Like, okay, if you are above this percent, you will be admitted. If you are below this, you are not admitted. There is nothing like that. You remember I told you one staircase?
Yeah.
Oh yeah.
That's the cutoff. But it's not exactly cutoff. Elements around the staircase, they have metallite character. They can be metals and non-metals, both. You're getting it? So I'll show you that. Let me finish with this, write on this, and then we'll come back to Avni's question. So metallic character decreases across the period as size decreases, force of attraction increases, and it is harder to lose electron. Is the language correct?
Yes.
Yeah.
Yeah.
Okay, so I think now this is about the metallic character across the period and down the group. Now I'm coming back on the question asked by Avni. Shall I clear this?
Yeah, I'm gonna take a screenshot real quick.
Yeah.
Yeah.
Okay.
Yeah.
Now she said that what is the cutoff and how I will come to know what exactly the size. The cutoff is this, Avni. It's an experimental observation, and they said that elements on the right side are non-metals.
Non-metals.
Elements on the left side are.
Metals.
So does it mean that arsenic is totally non-metal? No. The elements which are closer to the line, this line, they have both the characters. They are metals as well as non-metals. But as you keep going more and more to the right, the non-metallic character increases and metallic character decreases. So on the extremely right side of the periodic table, like this family, is completely non-metal. Extremely left side of the periodic table, this family is completely metals, strongly metals. Are you getting it? Okay, Avni, I think I just want to say that if you pick up an element, let's say you picked up this element, selenium. Now from the cutoff line, you know that the selenium is a non-metal. You know that, right? But do you think it has only non-metal character? It doesn't have metal character? No, it has metal character also. But which character is dominating? Which character?
The non-metal.
Non-metal. Like in biology, you know that uh, we have the characteristics of the father family and the mother family, but one of them is dominating, isn't it? So every nature is there, but whatever is dominating, that's the deciding factor. So in selenium, non-metallic character is dominating. Okay, tell me, what is oxygen? Metal, non-metal?
Non-metal.
But
Non-metal.
what is
Non-metal.
fluorine? Metal, non-metal?
Non-metal.
Yeah, these are non-metal. Fluorine's non-metal.
If this question comes in the exam, which one is more metallic, oxygen or fluorine? Do you think question will be wrong?
Oxygen.
Oxygen.
Yeah. Yes. So you can compare the metallic character among the non-metals also, and non-metallic character among the metals. Right? So both the characters are there. One is more, other one is less. Yes, Avni, Aditi.
I just saw this. I kind of forgot. It says that this group is halogens or something.
Halogens, yeah.
What does that mean again?
Name, halo. Halo means color, light.
Oh, okay.
This group is called as halogens. You know the name, children?
Yeah.
Names of the families. These are non-metals, very strong non-metals, all of them.
Alkali metals, I think.
Okay, I'll tell you again after this, finishing with this non-metal. So let's work with the non-metals now. Now we are going to check the non-metallic nature across the period and down the group. Non-metallic. Non-metallic means the tendency to,
Gain electrons.
yes,
Oh,
non-metallic.
non-metallic. Oh, gain electrons.
Wait, isn't it to like gain and share? Because like that's what
Yes, you're right, you're
metals
right.
do.
Yeah, but here we'll work with the gaining nature only. Okay,
Okay.
because we are comparing with metallic character. So metals losing, non-metals gaining. So you can work with gaining nature only. Okay, fine. So metals, they gain electrons to get the nearest, oh, sorry, non-metals. I'm so sorry, I'm doing errors.
Oh, yeah, non-metals.
Non-metals, they gain electrons to go to the nearest noble gas configuration. Right?
Yeah.
Okay, so answer my question. What happens to atomic size down the group? Size down
It
the group.
increases.
It
It
increases
increases
Give 3 reasons.
because one,
because the
Because
number
the
of shells are
the
increasing.
And
number of shells are increasing.
and then the number of protons also. Well,
The
no.
number of shells increase.
The distance increases.
yeah, that's because of the shells. Now
And,
discuss
yeah.
screening effect.
And then
Oh
for
yeah.
the
There's
screening
more.
effect, if there's more, if there's more of a
There's
screening
more-
effect, then that
and
means
some
there's more electrons that are not going closer to
To
the
the
nucleus.
nucleus. Yes, yes. So
Yeah.
less effective, less
nucleus.
nuclear charge, right? The nuclear charge felt by electrons is less. So I'm saying clearly again, down the group, number of shells are increasing. Inner shells are increasing. So screening effect is more down the group increasing. And due to this, the attraction between the electron and the nucleus is decreasing, which you can say due to this, the effective nuclear charge, the nuclear charge felt by electrons is decreasing. And outcome of these 3 is the size. Yes, Avni, you're looking troubled. Okay, okay, fine. So that's about the size down the group. Now, which element has more tendency to gain electron and why?
Um,
Oh, gain
Is
more
it
electrons.
I think it's
gain,
A
A?
Why?
I think
because because
I think A would
there's not
like
many
I
shells to
don't
this.
know.
Like
it would
more,
be
so
like more if
more
it wanted more electrons, then like it would have like a more
Wait.
attraction, I guess you could say. So
Okay,
But I think it's
so
B.
okay. So answer is A, Aditi. The first thing is that in A, the electron is more closer to the nucleus, isn't it? See the distance? Here, the electron is far away from the nucleus. Big atoms, their nuclei are far away from the outermost shell, where the electron will be added in the outermost shell. So now I'll ask you to speak one by one because earlier I could not hear anything from Kyra and Avni. So I'll ask you to speak one by one. So first, let's start with Aditi. Aditi, can you explain why A has more tendency to gain electron based on Coulomb's law?
To gain electrons.
Based on Coulomb's law? Okay, you start like this. Can you tell me in which case
Oh, okay.
A and B,
Because
the electron is more closer to the outermost shell and the nucleus?
the distance from the nucleus and the wait, are you talking about A or B?
Okay.
Both?
Can you tell me in A, the electron, is it more closer to the nucleus of A or far away?
It's closer.
So what happens to force of attraction if the R is less?
It increases.
So which one has more force of attraction on the electron, A or B?
A.
Yeah, that's the explanation based on Coulomb's law. You're answering AP question. Advanced placement
Oh,
chemistry
okay.
question.
And so does that mean that B, the distance is farther from the electron in the nucleus, so that means the
Attraction is?
attraction is
Yeah.
less
Now the
because they're
question
more
goes to,
apart.
now question goes to Kyra. The remaining part. Pay attention, Aditi and Avni. So which one is more non-metallic?
Which one is more non-metallic?
Mhm.
It's A, because since the distance is less, that means the force of attraction is greater. And because if the force of attraction is greater, it's like the opposite of if
Means it
the
has more
distance is
tendency
less,
to.
meaning that it would have more tendency to gain electrons.
Yes, you're right. See what she said, we can write it as reason. She didn't miss any word. Okay, now Avni, your turn. Can you just give me a beautiful statement that how this non-metallic character down the group changes and why?
Okay, so basically the non-metallic character changes because
Sorry.
as you go down the group, the size changes because the number of shells increase. So basically the the screening effect also increases, which is why the electrons aren't attracted more. So the size become
Bigger?
I'm saying metallic. So basically, the electrons become farther away. Well, they're
Mm-hmm.
not attracted as much as
Mm-hmm.
the metallic ones.
No, no, no. You
Wait,
talk about now
no, as the
attraction. As the okay.
as the non-metallic ones. So and also since the size increases, so the screening effect increases. The protons also are
Protons we are
increasing.
not going to talk about here because screening effect and shells are the dominating factor. So
Okay.
don't talk about protons down the group. That will confuse you. With increase in protons, there should be more attraction, but we are saying attraction is decreasing, isn't it? So
Yeah.
protons, increase in proton is not a factor here at all down the group. The factors are number of shells
And
and
shells.
screening effect. These two factors. Okay, now I
Okay.
give you a language, please write on. So Avni was trying hard, but still we are not clear so much. So let's make a beautiful language for this. So start with size. Down the group, size increases. And we know the reason. So don't why you know, right? So the distance which we are generally using R in our Coulomb's law, R, distance R, between the nucleus and the outermost shell. Focus on outermost shell. Outermost shell increases, right? Increases. Any confusion till now?
No.
As the distance increases, what happens to attraction? Force of attraction.
I
It
just had a
decreases.
question.
Increases.
It
Attraction
decreases.
decreases. As force of attraction decreases, what happens to the tendency of gaining electron?
I had a
It
question.
decreases.
Yeah. Let me finish this, Advani.
It
I'll answer your question.
decreases.
It decreases.
As the
Decreases.
tendency of gaining electrons, decreases, non-metallic character. Non-metallic character increases or decreases?
Decreases.
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 Decreases. Decreases. Yes, Avni, your question, please.
Yeah. So basically, this is like not exactly a question, but basically you said screening and shells are the main factors for something. Is it either non-metallic, or is it metallic?
Say again.
So you said that screening and shells are the main factors for either
Size
non-metallic.
down the group. That's it.
Yeah.
And the
Or
size is the one who is going to decide metallic and non-metallic character.
yeah. So basically, is it for the non-metallic
No,
character
no, no.
or
It's
the?
only for size. Okay, understand. Avni, now listen to me carefully. Non-metallic character and metallic character, we are comparing it from the size, right? We are saying if size is big, metallic character is more, non-metallic is less. Am I right? Is
Yeah.
it clear to all of you? If size is big,
Yeah.
attraction is less, it can lose electron more, but it can gain electron with difficulty, correct? So we are deciding metallic and non-metallic character from the size. That's it. And then size we are deciding down the group based on number of shells and screening effect across the period based on number of protons inside the nucleus because shells and screening effect are not changing. Avni, is it clear to some extent?
Yeah.
Don't worry, I'm going to ask plenty of questions and it will be more clear at that time. So when some concept is troubling us and I'm explaining again, and you are still confused, very confused, then wait for questions. Questions are the final teachers. What they can teach you, nobody can teach you. Learning by doing is the best learning. So groups I have written. The way I explain the groups, Kyra, you start. What happens to atomic size across the period? Kyra.
What happens to atomic size across the period? So
Mm-hmm.
across the period, it's the wait, on the top of my head.
Mm-hmm. Think slowly. No hurry.
Sorry, it's on the top of my head. I just can't remember.
It's okay, dear. Down the group, what happens to atomic size, Kyra?
On the group, what happens to the atomic size is so it's first like the shells, so it increases because of the shells, and then
Down the group?
down the group.
So what happens
Because
across the period? If down the group increasing, across the period definitely decreasing.
oh, the across the period it decreases. I remember now.
Yeah.
It's because of the it's because the
Yeah,
basically when there's
because.
more electrons and more protons, the force of
Mhm.
attraction gets greater, it
Yeah.
increases, and the
Uh-huh.
cloud of electrons come closer to the nucleus. Sorry, I remember now.
Perfect explanation. So size decreases across the period. What is happening to number of shells? No change. Screening effect? No change. You remember we discussed, Aditi?
Yeah.
Okay, so only factor is protons inside the nucleus, right? So as protons increases, attraction increases, so size decreases. As size decreases, Aditi, your turn. What happens to non-metallic character? Which one has
If
more non-metallic character, smaller or bigger?
um small.
Smaller, yeah,
Oh
because of
yeah,
more
small.
attraction. So what happens to non-metallic character as size decreases?
Non-metallic character increases.
Yes, please write down. Can you give me the reason, Aditi?
Because the tendency
To
I just
tendency to
had it, the the tendency to gain electrons
Increasing. Tendency to gain electron increasing.
the tendency to gain electrons is it's increasing
Why?
because
Because
the distance from the nucleus and the electron is getting smaller.
smaller, yes, getting smaller. Yes, you're right. The distance between the electron and the nucleus is getting
Getting
smaller.
becoming smaller.
Yeah. Is it okay?
Yeah.
Okay, Avni, your turn. So non-metallic character increases. She gave us the reason because the size decreases, attraction increases, right? Attraction increases. Non-metallic character increases. Avni, question for you, and please now listen to this question, all of you. Which part of the periodic table? Now we are done with the trend. Now the questions will help you in understanding this thing very nicely. Which part of the periodic table has the biggest atoms? Which part?
I think it's the first.
Is it hydrogen?
Hydrogen has how many shells, dear?
Oh, no. Is it the FR?
Wait,
I think
Tritium.
it's
OG.
Yeah,
I
yeah,
think
FR.
or F.
yeah. So this part,
Yeah.
can I say the extreme left bottom?
Yeah.
So write on this. Extreme left bottom are the biggest atoms in the periodic table. Extreme left bottom are the biggest atoms. Now, Kyra, can you answer one question?
Yeah.
You have written this extreme left are the biggest atoms.
Yeah.
No problem in understanding that. Why? Why is okay?
Yeah.
Because they have the maximum number of shells and maximum screening effect. So maximum that expansion, minimum attraction. So electrons, they go more away, more bigger size. Now, Kyra, can you tell me which part of the periodic table has the smallest atoms? Analyze carefully.
I think it's like the top right corner, like helium, neon, fluorine.
Okay, just leave those novel guesses. Then,
Oh, if I leave them, then I think it would be fluorine, oxygen,
yes,
that
these
area.
one. So can I say extreme right top corner?
Yeah.
Extreme right top corner are the smallest atoms in the periodic table. Please write on this, Avni.
Is it
Extreme.
okay? I just drew it on the periodic table.
You have written anything when you made it?
Yeah, I just like circled the place and said smallest atoms.
Yes. That's the reason I was asking you to take out the printout. And I said
Oh,
that
I
when
can
I'm
see
teaching you
it.
periodic table, do it on that printout. Kyra, you have printouts? No, again.
I have it. It's in another area in one of the other rooms, but I have the notes so I can just write it onto there after the class.
Okay, good. So, extreme left side are the biggest and extreme left bottom are biggest atoms. Extreme right top corner is of the smallest atoms. Now then the question goes to who answered the last question? Aditi, your turn.
Okay.
Your question is changing, Aditi. So think clearly, okay? If you want to take
Okay.
time, you can take time. Which elements are the most non-metallic? The extreme top bottom or extreme right up?
I
Okay. By the time,
Um,
Kyra, you also think, and Avni. Okay, so now I'm breaking this question into two parts.
maybe
Mhm.
is it the extreme right top corner?
Yeah, you're right. Why?
Because the non-metallic nature is when the electrons increase, like
When they tend to gain the electron.
they gain electrons and the attraction increases, so
Mhm.
the size decreases.
So
Because
the smallest
in the
atom, say
the
like this.
smallest atoms have the smallest
Distance of
shells.
separation of the electron from the nucleus, right? Is it okay? Okay, I think she tried to explain, and I'm very happy whatever she has said. Now let's organize it. Her sentences were breaking. So it's like this: extreme top right corner are the most non-metallic elements because they are the smallest elements with minimum separation, minimum distance of separation between the nucleus and the electron. So they have the highest tendency of gaining electron. Yes, Aditi.
Could you repeat that?
Okay, from where? Kyra, can you help us?
After extreme right top corner.
Let's see. Kyra, her mouth is stuffed with pizza. What is it?
It's candy.
Oh, you're eating candies. Okay.
Yeah.
But they are too sweet, isn't it?
No, I like
No?
eating them.
Which one is this?
M&Ms. It's like this kind of shape.
Yeah, my friend was telling. One of my student is my friend. She is from me. She started of your age and she's still learning. She's now, I think, in 11th standard. It's nearly 5 years, I think, 5 or 6 years from your area only, from this Seattle. She was asking me, do you know these candies? I said, no. But these are colored, right?
Yeah, they're colored. There's different colors.
So
But
the
they all
food dye or
I
something.
read once that the shells are made out of beetle skin. Well, beetle shells.
Oh. Okay, I'm never eating
Ew.
that again.
So I stopped eating them.
Okay. So actually, my advice is you eat them, no problem, but not too much because anything which is
they're
colored
unhealthy. They're
is
unhealthy.
not healthy. Yeah.
Food dye is kind of
Food
gross with me
dyes
right
are
now.
you don't know which chemical they are using, right? So try to eat what your mother is making in the kitchen. What she can give you, nobody can give you. Okay. So, but it's okay. Once a while, we can eat. I also do it. Okay. So I asked you a question that can you organize it that the top right corner? Oh my God, time is up. My other student is must be waiting. So this one and this one. I love teaching you children. I'm always crossing the time and my other children, they keep panicking. Okay, we can work from here in the next class.
Yeah.
Can you remind
Yeah.
me that we were working with the most metallic and most non-metallic corners of the periodic table, okay? So see you in the next class. I have to run out of the class now. See you. Bye-bye.
Bye.
Bye.
Thank you. Bye.